Okay, we're given an array of integers nums and an integer target. They want us to return the indices of two numbers such that they add up to target. So we can assume that each input would have exactly one solution, and we cannot use the same element twice. We can have the answer in any order. So let's look at an example. So we have our nums array. It's a bunch of numbers, and we have a target. Now they want us to find the indices or the positions of the two numbers in this array, which sum up to the target. So in this first example, we can see that 2 and 7, 2 plus 7 sums up to 9. And the positions of those elements are 0 and 1. So that's the result. And conveniently, there can only be exactly one solution with the inputs they'll give us. So we don't have to worry about any edge cases regarding that. We can see that the minimum number of elements in this array is 2. So that further supports that there has to be one solution here. Like there can't be only one number in the array. This is also 10 to the 4, so we can use a regular array or a vector in C++. This is also telling us that the numbers are going to be between negative 10 to the 9 and 10 to the 9, right? Greater than or equal to. So we can use a regular integer for this problem. Okay, so with the constraints out of the way, the naive approach here is basically going to be an n squared time complexity solution because you would be iterating over the array once. So let me draw this. So let's say we have this array. So we have 2, we have 7, 11, and 15, just some random numbers, right? Well, this is actually one of the test cases, and then the target for this is 9. So in a naive algorithm, we'd iterate through this array. We'd be at the 2, and we'd ask, okay, how can we find another number? Like, how do we know where the other number is in this array that potentially sums up to 9, right? With 2 to equal 9. Well, we would have to check all the other elements, right? So we would have a nested loop, and then we would check the 7. Now, in this case, we would find it immediately, but you can imagine in a very bad case where we have a huge array, you would check the first number, look at all of the other elements, check the next element, look at all of the other elements, and like this just becomes very expensive to do, right? So, but what if there's a way we could save the number, right? So this is where a trade-off of sorts is going to come in, because there actually is a data structure for this called a hash map, right? So I'm just going to put our hash map down here. And so this is our hash map. Now it's going to have a bunch of keys, which we can access in big O of 1 time. And those keys are going to have values. And basically what we're going to do is, as we're doing a single pass through this array, so this is O of 1 time to access these keys, right? So instead of an array where you have to check every element, it would be in time, where in is the size of the array, right? So we're going to use this map, and we're basically going to store at each element we see, we're going to store its key in, we're going to store its value as the key in our map, and we're going to store its index. So this is index 0, index 1, index 2, index 3. We're going to store index 0, right, as the value in the hash map. That's for that key, right? So, and this is going to be O of n space, because in the very worst case, we're going to have to store every single element from the input array there. So, yeah, so let's walk through this approach. So we're going to have the 2, right? We're going to store that in our hash map. We're going to store its position, which is 0. Okay, so on the next iteration, we're going to check, okay, let's check our hash map. Is there any, so like, first of all, we're looking for a specific number, right, at each number. So at 2, we would have been looking for a 7. We would have checked the map. Is it in there? No. Okay, well, we store the 2. At the 7, we're going to look for a 2, right? Because that's the number that would add up to 7 to give us 9. So we're going to be looking for a 2, and we find it in our hash map in constant time, right? So we could right there exit the loop and return the indices, which are 0 and 1, right? So this is going to be the, let me use capital T. So for the time complexity, we're going to have big O of in time. For the space complexity, we're also going to have big O of in space. So the time is because we're doing one pass, we have to look at each element once at the worst. And for the space, it's going to be big O of n, because at the worst case, we're filling up this whole hash map with n elements from the input array. So that's the whiteboarding. Let's do the code. So in C++, we already have all of our imports here and the function signature. But we're just going to create a hash map in C++. That's an unordered map. We're going to have integer keys and integer values, right? So that's key, comma, value. Those are the types. And we're just going to call this hash map. Okay. And next, let's just start looping through this nums array. So we could say auto and do, for auto num and nums. We could also, I think for this problem, it's better to actually use an iterator because we actually care about the index for the result. So let's do it that way. So we're going to do, I equals 0. We're going to say, I is less than nums.size. And then we're going to say I++. So we're going to keep incrementing I in the range of 0 to 1 under the size of nums, because it's a 0 indexed array. So that's our loop. Now, the first thing we're going to do is check our hash map for the other number. So let's actually make the other number over here. So int other num, and we'll never use this value here, but let's just initialize it to something. So we're going to say our other num is going to be equal to the target minus the element, the value of the element at this position. Okay, now we're going to check. We want to know, okay, is the other number in our hash map? So we're just going to say hash map dot contains and then other num. Okay, so if it is indeed in our hash map, we can simply return those two indices, right? Because we have found the result and we're done, right? So it's going to be I, so the index of the current element, and then the index of the other num, which is, how do we get that? Well, we stored it in the hash map as the value. So we can look up the key there, which is the value of other num. Kind of lots of keys and values, and it's important to know which are which, right? So we're returning this as our answer. And the only step at this point is if we didn't find the solution on each element, we're going to store it in the hash map. So we're just going to say hash map nums I is equal to I. Okay, perfect. Okay, so that should be all of the code here. Now, yeah, let's just go ahead and run. Okay. Okay, so sometimes this is just a warning, but in this version of C++, we're getting an error because we're not returning a value in all control paths. Even though the answer guarantees there will only be and there will always be one solution and exactly one solution, right? So this line will always be reached. But nevertheless, this is illegal. So we have to return something here anyways. So let's just return -1 and -1. Okay. Okay, cool. I guess we're the fastest in the world too. So nice. But yeah, hopefully this is helpful, and gonna go make another one of these. So I'll see ya.